All right, here we go. Solve the equation 6 times the sine of 2x equals 5. And our first step, so we got 6 times sine of 2x equals 5. We're first going to divide both sides by 6 and get that sine function all by itself. And then after we do that, things are really gonna open up. And actually, let me even just skip right to that part. So we've got sine of 2x equals 5, 6. And that was from dividing both sides by 6. But sine of 2x equals 5, 6. And so notice what's going on here. It says that this is for 0 is less than or equal to x, which is less than 2 pi. So this is within one time around the unit circle. But what we have is 2x right here. And there's a few different ways to approach this. Some would be to substitute this part in for a y and for 2x right there. Solve for y, and then from there solve for x. And that's a pretty good way to do it. But what's going to be happening, let's kind of visualize for a second our unit circle. Where would sine of an angle, so if we had sine of y, or sine of theta, sine of alpha, I don't know, sine of something, is equal to 5, 6. Where would that take place? And so 5, 6, that's less than 1, so it's less than our maximum, and it's positive. Now sines are y value, so it's got to be in the first and second quadrants. Okay, so whatever the angle is, not theta, but even just 2x. Wherever 2x is, it's right there and right there. Now we've got to kind of go from there to figure out what to do. And here goes. So got a graphic I want to show you here. This black line is y equals sine of x. That's just our normal graph. This blue line is the function that we actually have here in this problem. It's sine of 2x. So just typed in y equals sine of 2x. And notice that it's double the frequency. Its period is half of the black function, the sine of x function. That by the time sine of x does one complete period, our blue graph, that's y equals 2 times sine of x, has completed 2 of them. Now the red line, that is y equals 5, 6. So where would those functions be equal to 5, 6? And here's kind of what's going to happen. Notice point, this is point C right here, or point B and C are kind of, they're too close to each other. They're right there on top of one another. But the point where the black graph, y equals sine of x, equals 5, 6. Notice where that happens. It's right here. Now that point corresponds to A. If we were to divide that x value in half, that's the x value of point A right here. Likewise, once it starts coming down, so that's first quadrant. Now once we're in the second quadrant, point D right here, when that x value gets cut in half, that's now where point C is at. It's halfway to D, so that 2x, it got divided by 2, and now here's our new x value. By the time that this sine function hits 2 pi, our limitation, it's not going to hit 5, 6 anymore. However, the blue graph, y equals 2 sine of x, it will hit 5, 6 twice more. Now to find out where those points are at, we're going to have to kind of extend our black graph right here, the sine of x graph, past 2 pi. Past 2 pi, and see where it hits again. So G is the next time, so that's basically point B back here plus 2 pi, plus 360 degrees. It's one period further from that. And that point right there, if it were divided by 2, if the x value here were divided by 2, it would end up at E. Likewise, H, that's corresponding to point D. If you added one full cycle, one period, to D, we would end up with H. And that value, if it was divided by 2, would give us f. Okay, and now I realize this is all real confusing, but hopefully this is a few different ways to think about what's about to happen right here. So our next step, we've got sine of 2x equals 5/6, and we need to figure out what that angle is. And so what we're going to use is our inverse trig functions. So sine inverse of 5/6 is equal to 2x. There's our angle. Now let's see, clear that out. So 5 divided by 6, and then the inverse, sine inverse of that, oops, let's get it into radians instead. So 5 divided by 6, inverse sine, and so we've got 0.9, around to the nearest hundred, so 0.99. All right, 0.99. 0.99 is what the sine inverse of 5/6 is. And we might be tempted to set that equal to 2x and just divide. However, we're going to miss what we would just found right there was a. We found this point over here, the c value, and which was 0.99. And if we divided it by 2, we'll end up at a. But we need to get all the rest of the ones there on the graph. And so here's how we do that part. Again, it's a lot of material on this one problem, so do feel free to rewind it, rewatch it, and we'll also cover it in class as well. So if our original kind of domain here was 0 was less than x, which is less than 2 pi, but we're dealing with 2x, we need to kind of double the domain. So multiply everything by 2 to get to our 2x. And sorry, that last one's times 2, not 2x, times 2. So 0 times 2 is 0. 2 times x is 2x. There's the domain that there's what we have right now, that 2x, which is less than, just less than, not or equal to, but less than 4 pi. So everything got multiplied by 2. So what this represents is how back over here, we have to extend past 2 pi. We've got to go a full another cycle to get these other values of e and f that we would miss otherwise if we only considered the values where the original function was within one time around the unit circle. All right, so here's how we do that part of it. So 2x, I'm going to kind of break this into, in quadrant 1, we'll draw a picture up here as well. In quadrant 1, where does 2x equal where would 2x, sine of 2x, where would it give us 5/6? So sine being positive, that would be an angle of 0.99 radians. So there's our first answer, is 0.99 radians. It happens again in quadrant 2. Again, sine is positive. So this reference angle of 0.99 radians, but that's going to be pi minus 0.99 radians. So 3.14 minus 0.99. And so this angle itself would be 2.15 radians. And that's happening in quadrant 2. 2.15 radians. Now, this angle here, remember we had to double our domain to find the other times that basically where e and f would happen. We have to double the domain of the of the sine function so that we can get these g and h values so that we're able to cut them in half. So even though our domain is limited to 2 pi, we're going to extend out to 4 pi so that when we divide 2x by 2 to get just x, we'll have those values. All right, so this would be, let's go with green this time. This would be at let's see, could make it a little darker. 0.99 radians plus 1 full time around the unit circle. So that's 0.99, so quadrant 1 again, but it's going to be 0.99 plus 2 pi. So plus 2 pi, which will give us, I believe, let's see, let's just use 3.14 times 2, so 2 pi, plus 0.99, so we're at 7.27. 7.27 radians gets us back to this same place that will have us with a sine value of 5.6. Likewise over here where we had 2.15 radians, if we go one full time around the unit circle, that's adding 2 pi. We'll end up with that same terminal ray. And so let's see here, 3.14 times 2, and then that plus 2.15, and we end up with 8.43 radians. 8.43 radians. That is when 2x, sine of 2x, gives us 5.6. We need, and what we're going to do here is now divide everything by 2. So it won't necessarily be in quadrant 1, 2, 1, 2 anymore. But we're going to get back to just x. Not 2x, but just x. So x is going to be, and we'll round up here, but 0.449. I guess we won't round up. We'll round up. 0.5. 0.5 radians. 2.15 divided by 2. So 1.08 radians. 7.27 divided by 2. So it looks like 3.64 radians. And 8.43 divided by 2, 4.22 radians. 4.22 radians. And so those are our answers. That's what x can equal. That from 0 to 2 pi, so again, what x is equal to, notice that none of those don't go past the 6.28. These are all between 0 and 2 pi. Those are the 4 values that when plugged in for x will make this equation true. And notice there's a lot more work than just ending here and getting perhaps 0.5. We had to go the full rest of the way, remembering that this angle is true, but at the same time, this angle over here as well, same reference angle. And then going to those 2 reference angles 2 times around the unit circle, so that when we divided it and got just to x, we got all of our possible answers. And so one last time to look at the picture here, what we just found, here's our first one, there's our 0.5. Here we have the point, I think it was 0.08. What was the other ones? Sorry, 1.08 was that last one, and then 3.64 and 4.22. So 3.64 right there at E, and 4.22 right here at F. We were able to find all 4 of those locations based on finding the 4 locations here on the sine graph, and then dividing the results by 2. A long process, a lot of work, but you really can get your way all through it, and this will make more sense the more we go through it and the more you get practice on it. So watch that a few times, pause it where you need to, but I do hope that helps. All right.